Good afternoon. How are you all doing today? Today I'm going to talk about application security from tamper evidence to tamper resistance, and how to build rigor into our software development lifecycle without affecting velocity. All right. So quick background on myself. My name is Jason Montgomery. I'm a VP of security at DataRobot. And a few years ago, I was the CTO and co-founder of Nexosis, which was acquired by them about 2.5 years ago. Previous to that, I've also been a principal researcher at Veracode. I've been an instructor and author at SANS, and I'm an avid pinball player competitively, and I like to refurb and repair machines. That's a quick background on myself. I've had about 15 years of experience in application security in particular, and I've been a guest of the Ohio State University over the years, and it's great to be back. So thanks for having me again. Last year, if you came to my talk, we talked about the DevOps lifecycle and building security into this process. And this year, I want to dive in a little deeper to look at the entire pipeline and really how to add rigor at every stage. And that's a really important aspect of security. And the main theme you'll see is the whole principle of shifting left. Unfortunately, that term is now becoming an annoying buzzword within the security appliance, and a lot of products, everyone's trying to get you to shift left, and they're trying to sell you products that shift left. However, it's a really good principle. It's like moving things as far and as early in the development lifecycle as possible. So just a quick recap on the DevOps lifecycle. And again, this is, and it doesn't really matter what type of development lifecycle you're using. If you're not doing DevOps, that's okay. What I want to show you is some ways to build automation, no matter what your life cycle is, so that you can actually incorporate security at every stage. And again, a lot of these principles will apply even if you're not doing true DevOps. So again, just try to take away the automation points. And again, I think these have really, really brought in some really important capabilities that are really helping us provide security at every stage. So we're going to talk about plan, build, continuous integration, deploy, operate. This is Atlassian's off their website. This is the infinity logo you always see for DevOps. And then there's a continuous feedback, and it's sort of round and round you go. Sometimes you stay looping on one side before you deploy if there's a problem, or you live in operations trying to patch. So again, you're moving back and forth between these two sides of the circle on this infinity logo, with collaboration and security at every stage. So in the middle. So the problem for the security person who is used to turning around security reviews in a month or 2 weeks is they're just being shoved out of the game. There's no way with how InfoSec is currently configured that they can keep up with that. So InfoSec gets all the complaints about being marginalized and getting in the way of doing what needs getting done. And this is from Gene Kim, the author of the Phoenix Project. I used this quote last year as well. It's really important the way development and developers are working with these quick pipelines, these quicker release cycles. InfoSec sort of doing these checklists and rubber stamp security and things like that is not really getting things done. What we need to do is make it everyone's job, move it earlier in the life cycle, bring in a lot of automation. So we have to retool security, and we have to retool developers and have them own that part of it. And that's what we're going to talk about today. Our application lifetimes and life cycles and development processes have changed. We have these development processes, which are waterfall. And on the left here, we have an application lifetime, maybe months or years. And as we move down, we move to months and weeks, and then sometimes just weeks and days. Then we look at development processes as they move from waterfall to agile to now DevOps. Application architectures used to be monolithic, still are, N-tier, they still are, but now microservices and cloud native and a lot of these new technologies that are basically pushing APIs everywhere, full automation everywhere, are the new sort of model for designing applications. We started with physical servers, moved to virtualization, and now we're using containerization and orchestration with things like Docker, Kubernetes, and other technologies in that space. And then we have our application infrastructures going from hosted to data center to cloud, or on-prem cloud, or private cloud, as people like to call it. Everything is sort of moving down to this life cycle at the bottom where we have DevOps, microservices, containers, and cloud. But again, if you're not doing all these things, that's okay. There's still automation we can add, but things are changing. And if people are gravitating towards the bottom, without automation, there's no way security will succeed. It's a fun tweet from Pete Cheslock. Everyone seems to like this representation of DevOps and security from my talk at DevOps Days in Austin, right? And we have the proverbial security cleaning up the complete and utter mess of DevOps. And that's not really a fair characterization. I think security couldn't keep up with the pace of the new development processes, right? So we have to find a way to break down these silos and work together. Another really nice piece of material on the topic, the DoD has published the Enterprise DevSecOps Reference Design. Once the DoD and the federal government have sort of defined a standard and they've put NIST behind it and all the other sort of requirements, you know it's at least mature enough to be adopting some of these practices. And so we want to dive in, and you can see that an Infinity logo in the middle with Dev on the left, where we're planning, develop, building, testing. On that outer ring, we have that security tier where we want a threat model. We want to do secure coding. We want to write security as code. We'll run through examples of security as code today. We'll talk about how to do static and dynamic analysis. That's STAST and DAST. Where pen testing can fit in, and then moving on to the operational side. We're going to focus a little more heavily on the left, and then we'll touch on some monitoring on the right as well. It's going to be hard to dive into all these areas. It's a massive topic, but I just want to lay some groundwork and some quick wins so you can bake security into that life cycle. So DevSecOps is an organizational software engineering culture, and it's a practice that aims at unifying software development, security, and operations. It's a unification. It's de-siloing. DevSecOps or DevOps is not a role, a person, or a title a person has. It is just the principle of de-siloing these three groups of people and putting them on teams together to collaborate. Main characteristic of DevSecOps is to automate, monitor, and apply security at all phases, right? So here are those phases, and let's just jump through these real quick. Additionally, right, we want to look at this concept, and DoD sort of proposed it as a software factory. Repeatability is key, especially if you want to do automation and testing at every stage. It's really important that we have a factory in mind. Everything is not a beautiful, unique snowflake. Your code might be, but where it lands, the containers it lives in, all of those pieces of the infrastructure around it, and all of that should be effectively a factory that you can churn out, you can measure at every step, and you can get a good velocity of your code and your security reviews in this process. So here's an example of how they're planning at the top stage. We have the DevSec and Ops teams at the top working together in this DoD model. And they've got all their tools, and then they move into the development phase, and this is the software factory pipeline in their ecosystem. And they push to the staging production environments as well. And then there's some monitoring tooling in that operations area. And there's some approvals from enterprise and local security. It's a very formal process. So one thing you'll see with this, there's a lot of steps and a lot of rules. Of course, this is the government who built this actual process, but we're just going to borrow some of them. We don't need all of them. Depending on what you're building, you may need some if you need to meet certain compliance. But again, we just want to learn from what they've done and really wrote up and codified in their life cycle. So the big takeaway, I think, is going to be automate all the things today. And let's look at how we might do that. So the plan stage is the hardest stage, I think, to automate, right? Because you're really gathering requirements at this point. But there are some important key security factors to maybe decide. And I think you could dive into all these sorts of things, but the big ones are privacy risk assessment these days, and your risk level acceptance. Is this a app that has lots of sensitive data? Does it have lots of privacy data from people in our organization or external people who we're interacting with? What is the risk assessment? What are the applicable laws? Those sorts of things. We want to identify security requirements. And that's just, again, it's the normal sort of confidentiality, availability, and integrity, that triad there. Risk assessments, other things. Again, this could be really formal. This could be really lightweight. I want to share with you a lightweight process for getting this done. That's planning. Then in the design phase, we want to map our theory from requirements gathering stage to reality. We want to create our software requirements, attack surface analysis, and threat modeling. And we're going to dive into threat modeling here in a minute, just to give you a quick overview of what that can look like and how that can help in this process. A lot of other activities you could go into, very formal. You might not be doing all that, but they're here for the sake of completeness anyway. We're not going to, again, cover all of these things. The two big things I want to take away from, or I want you all to take away from, is when you're planning and choosing, right? It's the baselines. It's how do we create a standard foundation to build on so that as we move through this continual release cycle of our software through these pipelines, we always have a good, sturdy foundation. And so that's what are our AppSec standards. And so we could go through the OWASP top 10. We've done that a million times. We could talk about proactive controls. But now there's actually a very formalized engineering requirement verification standard. We're going to dive into that just at a really, really high level and show you some of the requirements. They're super powerful and a great way to derive requirements. Typically when I'm interacting with development teams and they're like, hey, what are the security requirements? And I'm like, that's really hard. It's the context and it's what language, and there's all these like confusing things. To sort of understand and know and be aware, and that requires some dialogue. But at a very foundational level, there are, hundreds of requirements that one could have in different domains in our applications that we can just hand over and let the engineers worry about. And that takes the burden off of security, and then they can just be more part of that validation stage. We'll talk a little bit about CIS benchmarks, choosing how to have foundational secure requirements in our operating systems, containers, web servers, databases, so on and so forth, through these the CIS benchmarks. Real quick, ASVS, Application Security Verification Standard from OWASP. It's an incredibly useful project. Not all of their projects are super useful. This one is. Because it defines 3 risk levels, you can see on the left here, level 1, 2, and 3. I'll just sort of zoom in here so you can see that. And then the applicability, this is sort of your risk level. So you have all applications maybe meet level 1. It's a little lighter weight requirement. At level 2, you might say all of our apps must meet level 2 assurance requirements. And then level 3 is the highest assurance we can get. It's going to take more rigor, more time, more effort. And so with these 3 levels, you can derive requirements out of this standard to help you define exactly how you should be building your applications. Then when you move into the building phase, right, it talks about particular aspects and how each level meets those requirements. Again, we're not going to dive too much into this, but they have the building configuration deployment, and assurance and verification. All those requirements are in there from the beginning, and it's incredibly helpful. So what areas do they cover in the secure coding requirements? Secure architecture, design, and threat modeling requirements in Section 1. Section 2 is going to cover authentication verification requirements. It turns out these map directly to NIST 863 standards. So if you want to meet those, all of these requirements actually map over, and you can actually meet NIST standards with them as well. Session management, access control verification, sanitization, and encoding requirements, stored cryptography verification requirements, error handling and logging, and again, a few more. And I won't read them all to you. But here's an example of what some of those look like. So for secure coding requirements, if you dive into section 2.1.1, it's got a requirement. You can see level 1, 2, and 3. We can see what common weakness enumeration from MITRE that solves for, and what NIST 863 standard that maps to, right? So verify that user sets passwords are at least 12 characters in length. Now, if you have different policy, and if you have different standards in your organization, what you do is you fork their Git repo, you tweak the requirements so they meet your organization's requirements, and you run off those, and then you just kind of keep them in sync and update them as time goes on. It's all in Git, and it's in the bottom right-hand corner in the link. And these are incredibly useful requirements because, one, they're written in a way that an engineer can code against. They're very, very clearly defined. So a frustrating thing for engineers, I think, is to get requirements that aren't actionable. Like, well, don't do this thing. And it's like, well, that's okay, I won't do that. But what do you need me to do? What are the real requirements, right? And we want to dive into those. And this is going to be a great map. The other thing is you can do test-driven development against most of these. So you can write unit test cases for all of these. And if you pass them, you've known you meet the requirement, you can actually measure that. And if you create a regression, the test will fail. And you can see that you need to fix a bug or an issue with that specific requirement. So ASVS, super powerful. So let's talk about threat modeling real quick. Let's dive into this at a very high level. So all models are wrong, some are useful, right? Modeling is not perfect. It's like developers and documentation, right? It's rarely kept up to date. And so this is the challenge. And so as far as doing this sort of agile and iterative development, kind of bringing in threat models are a super important way to quickly try to tease out security requirements where you might have gaps. And that's the real important part. So let's look at threat modeling attack trees real quick. This is one approach you could be able to take. And there's a lot of these on the internet. You can come up with these on your own for your particular systems. But let's just dive at this one that's going to look at how do we attack this safe. We want to get into this safe without the owner allowing us to get the secret treasure inside. So attack trees is going to model this at the root node as the goal of the attack. And then you're going to have all these leaf nodes off of it that branch with certain conditions that need met to actually reach it. So at the top level, open safe. And then to do that, I need to figure out how to pick the lock, learn the combo, cut open the safe. Maybe the safe was installed properly, or maybe I install the safe improperly if I'm the safe installer. And you then can measure things like, is this a possible thing to do? Is this impossible? And you work your way down through these attack trees, and you can attach dollar amounts to each one of these, amount of effort, if special tooling is required, and you can create a sort of path to the lowest hanging fruit, the easiest path into your system. And so you might say, well, learning the combo is easy if I can find it written down, but maybe you've determined that's impossible, right? Maybe you don't have access, or maybe no one wrote it down near the safe, right? So you tag those impossible. In this case, you don't know how to pick locks, but maybe cutting open the safe is possible. You've got a tool that can do that. But again, that might be impossible for other reasons. You might be possible to bribe the person with the combination way down here. And again, if you can listen to the conversation and get the target state the combination, right, that might be another way. One's possible, one's impossible, so you can eliminate that one. The whole idea behind these is to build and sort of systematically work through a particular security control and figure out how to get into it. They're not as commonly used, but these days, but it's a really important way. Another way I want to talk about is through data flow diagrams. And this is a little more popular through Microsoft's Stride and Dread methodologies. Cigital has a nice one as well that they've shared with OWASP and many other places. And effectively, we want to gain an understanding of the system. So we might do some interviews with different people. We're going to collect maybe different diagrams. We have layer and logical diagrams from developers. Maybe there's a deployment model from infrastructure. And we can kind of overlay these. We can determine what's in scope. And then we can do data flow mapping. To create the simplified model from our layer, logical and deployment models, that's going to give us a really nice model to focus in on. And then we're going to look at attack possibilities. We're going to tag assets, security controls, and threat agents. And so just to give you a quick look what that might look like, here we have sort of a sample model. Let's see if I can zoom in here for you. And so we have a user who's going to access a web application. All right, and we have a data flow line between these. Then we have some trust boundaries, these dotted lines. This is the user's machine, this is the user's LAN, and this is the internet at a broader level, right? And those are all trust boundaries within the user's scope. Then we have over on the right, maybe the data center or a cloud provider. We have the web app, we have other things deployed in that area like the WordPress blog. We may determine that's out of scope. But we still want to put it on our diagram. We're not going to dive into it, but we're just going to put it there as a thing that's in that area maybe. And then we have a couple APIs, payments and users APIs. And then there's this external credit score provider. So you draw your data flow, you draw your components, and then on the far right, you have your storage, right? Payments table, logs table, users table. These flow into analytics table, some sort of data lake or analytics store. And then the WordPress tables over here as well. So you draw the diagram, you put your trust boundaries in, and then you tag your assets. These are the things you need to protect, right? And so maybe you have credit card data coming in through this connection that's going to communicate to the payment API, right? So you would tag that AO1, and then you put that in the table down here. That's credit card data. And that then is going to flow to the payments API, which also has the same payment data, right? Then you might look at user PII, AO2. Well, that's going to be in the user table. AO3, the credentials are stored in the user table, so on and so forth. So you document all your assets, the things attackers are after, session cookies, communication channels, things like that. Then you decorate your threat actors. You drop those in, and you label those. So TA 0, 1, 2, 3, and 4. And here we want to look at our canonical threat actors. So we could try to invent who's a real threat. We could invent countries who may want to get us, or bad guys, or we could just go with canonical ones that basically say, like, there's an unauthorized external internet-based attacker, there's an unauthorized internal external client-side LAN-based attacker, authorized external malicious user, authorized internal malicious user, or system admin. And then if you're in the cloud, you can add another one, authorized malicious cloud provider admin, and then a mobile client, malware on jailbroken rooted devices. And you just bring these in. And TAO1 is a malicious user right here. TAO2 is that LAN that user's machine is on in their home network, or maybe in an untrusted coffee shop somewhere where someone might be eavesdropping, or wants to add a man in the middle. And then, O3 here could be a miscellaneous compromised credit score partner, right? So sometimes our partners get compromised. We have to think about those threats. And then you come through and talk about your security controls, and you drag those in, and you talk about, well, we have authentication here. We use password hashing. We use TLS. And you build a spreadsheet effectively of these, right? And you can, if you have a threat actor in a particular trust zone, trust boundary, and you have an asset you need to protect, and that actor has access to it by crossing a trust boundary or being within the same trust boundary, you better have security controls to solve for it. And it's really that simple. And you can document all those and keep it formal. Typically, we'll just take a small slice of a system. So if you're doing more agile development, you're doing 2 weeks of work, or maybe you're planning something a little bigger for the next, couple sprints, you build a really narrow threat model that just documents the piece you're working on, and you just look at it there and you derive requirements out of there. So that's a really important part of threat modeling. And so there's a great tool you can get. And this is, if you're familiar with draw.io, it's a way to draw diagrams online. It's a pretty neat system. And if you go to, and I think it's at app.diagrams.net. So if you go here to draw.io, you'll get redirected here. But I don't want my threat model on the internet, right? So I can get the desktop version here. I can get an installer, and I can install a local copy, which is what I'm running now here, right? And I can load up and save local files. It saves the format in XML. And here we're going to use the Juice Shop today, the OWASP Juice Shop, which is a project. It's a vulnerable web application. It's very insecure. And it models an e-commerce site that was written in Node.js, and it's very poorly written. There's lots of hacks and flaws you can do within it. So within this website, right, I drew a quick threat model using this and some stencils. And so there's a link to the stencils as well in the presentation, and I can share those with you all as well. But you download these stencils, and you basically can just build a real quick model. And I modeled this app, and I can see that I have my threat agents, my threat actors. I have some assets sprinkled around. There's a SQLite database. There's some files on the disk that run the website. And I can even look through here and just see quickly that this user has access to the Express server. And it turns out I found there was an FTP service, legacy service, that was found also installed on that system, right? And so that may be a way to pivot to disk access and make exploits that way. What are the controls around that, right? So we model the system very quickly and very easily with a tool like this. And again, this diagram took me maybe 20 minutes to make with a little bit of understanding of the system. So as engineers, programmers, developers, what have you, doing threat models like this is not a high bar, right? Again, you're not trying to document absolutely everything. You're trying to get the most obvious things and make sure your controls are implemented properly. And you can do it all in the comfort of, without having to buy Visio licenses and things like that. You could also do this in Visio. And then Microsoft has a formal threat modeling tool. It's kind of Windows centric, so I don't tend to want to use that one because a lot of the systems I'm dealing with are not Windows based. So that's threat modeling in a very quick for the plan and develop for the plan phase. Now let's talk about the development phase, right? Again, we're going to move through these really quickly because there's a lot of material to cover. This is where all the development happens. You have your infrastructure, design, security, test, database, application. This is when everyone's coming together to build all these assets and pieces and parts of code. There's a code repo involved as well. And there's pipelines typically involved that are running unit tests and things like that. And there might be auto-generated documentation, right? If you're publishing APIs, it's a great place to do this. And we want to make sure we define and write code for all these things. So the difference here is we're not, with DevOps, is that the developers, the operations and security people are coming together, or someone's putting on the security hat here and they're jumping in and they're going to help define the standards. They're going to say, use the ASVS. Here's the level. Here's the risk level of that app. Here's the compliance you need to meet. So when you write the code, you have that information readily available, and you know how to write the apps and tests and things like that. Let's talk about some of those tools then. So ASVS I mentioned, our integrated development environments. Those are all, we're very, very used to those, but there are plugins we can actually leverage that are going to help us, or there's automation we can write in our plugins that can help us. So just as a quick example, let's take a look at this Juice Shop application from OWASP real quick. Let me open it up real fast. And you can see that this is your standard, this is a WebStorm IDE from JetBrains. You could be using anything. You could be using IntelliJ, you could be using PyCharm, you could be using, Visual Studio Code, whatever, right? There's tools for all of these. And to do automation in here, right, you'll see things like linting, right? That will validate that things are actually written according to a standard, right? These are things that I do before I ever submit code. So in the package JSON here, there's a lint stage that runs a command that's going to use npm and ng to sort of run through the front end, make sure everything is as organized and meeting all of our standards as possible. The more automation and the more discipline we have with how we develop our code styles, how strict we are with naming and all those things. One, make it easier for other people to jump on the team, identify things that are deprecated or things we don't want to be using anymore, things that have security concerns. There's a lot of things we can do in the IDE that identify that. So here, I'll just jump in a zoom. You can see that we have async is deprecated, right? So it's giving us clues, and we can click on those links in our code, and it's going to show us the line of code that has the problem. Right? And we can work through these until our linters are cleared before we ever commit our code. And that's the principle of shifting left, is we're running something locally in our IDE. We're writing tools and integrating tools into our development environments that help with this. Another important one, and all our unit tests are in here, our end-to-end tests. I'm not going to go through that stuff. That's pretty probably familiar. The build stage, again, you can do a lot of things in here. Another really nice one is we have SonarLint. I can just click a button and I can analyze with SonarLint, and that's going to run through my whole project, and that's going to look for, using their linting rules, a whole other series of issues in my repo. So it's going to look at my HTML files, complain about things that are not compliant. It's going to look at my JavaScript files to see that I'm redeclaring variables, and it can cause confusion, and these sorts of things can cause and lead to security mistakes, right? But this is also just good hygiene from a development standpoint. But it's also going to bring in a lot of the hygiene has side effects that cause security bugs and issues. So the more of this we can integrate into our process, the better off we're going to be. And so again, we're going to get a whole series of things I can ever do before I commit my code to a GitHub repo. Meaning, by the time I'm checking code in, and if you start with this at the beginning of a new project, especially, it's nice, is you can keep things clean. You can define which lint rules you want to ignore, perhaps. But again, this is going to provide a lot of hygiene and good coding practices, because that is also, the number of bugs also correlate with the number of security vulnerabilities in our app. And if we can minimize those, by using good programming practices that linters are good at identifying, that's a good approach to take. So that's a couple quick, dive into what we can do in our IDE with some security plugins, or just really just normal plugins that keep our code hygiene good, right? Let's talk about source code repository. So we have GitLab available. We have a repo of security plugins we can use, and we have code quality review tools. So let's take a quick peek at those as well. So I showed you SonarLint. Again, it's a free plugin, runs in Visual Studio Code, most of the JetBrains browsers, and you can run it in your CI/CD pipelines, in your Jenkins pipelines, in your GitLab pipelines as a step. And then you can send the results out into their tooling, or you can send it out into a SonarQube dashboard, which is another open source project that allows you to display these quality measures for everyone else to see in your organization, and to work through them and make sure. But I'm getting a little ahead of myself, right? That's CI/CD. We're talking about development tools now. Infrastructure as code. This is a really sort of important thing as well. There's actually security requirements in how we automate our infrastructure. And using DevOps tooling, there's, if you're writing Terraform, or if you're writing Ansible, if you're writing Docker files, there are standards and security implications in all those stages. And there are tools and scanners out there that can actually look at that stuff as well in an automated fashion, so that we know we have some good quality there as well. So again, we're moving around here in the develop. We talked about secure coding and security as code. Then let's dive into that. So what is security as code? This is a new concept in the sense that it's like, well, what do you mean security as code? Isn't that secure programming? And it's like, no, this effectively is the security team. So we talked about the developers putting their code in the GitHub repo. We talked about operations, maybe putting all their code in the same repo. And the security teams should be integrating all of their things into the same repo. And this is the principle of GitOps, which is a newer sort of philosophy, that the Git repo is the single source of truth for the desired state of the entire system. The big benefit of that is you can have all of your security checks are defined clearly in your repo. All the infrastructure is defined, all the containers are defined. And so you have a single source of truth for everything. You don't have to jump over here or jump over here to figure out what's going on. And that's the principle of GitOps. And I would recommend looking into that. It's not a super complicated concept, but I've worked at companies and I've worked in systems where it's like, well, this thing fires this thing in this repo, and you have to do a PR across these 4 repos, and those come together to like form Voltron or something, and it gets really complicated and confusing, and no one can figure out what's going on. The simple, principle, keep it simple, really applies here as well. So we want security as code is to build security into our repos, into our CI/CD pipelines, into our local GitHub repo. So we could do, our Git repos. So we can do things like, pre-commit hooks. So right before you commit code, maybe you scan it for leaked passwords with a tool. That can do that on the machine, or maybe you run through a security linter like dlint or bandit for Python, and you can do that before it ever leaves, and it's all triggered with the GitHub Git pre-commit hook. Sorry, mouthful. That's really important. So the more we can move stuff into the development area and then start integrating these into the repos, so that when they end up in GitHub, we're going to have a lot of powerful tooling to build in our pipelines, because we can leverage it all there as well. And then we need security-related APIs. Most security tools now you buy have APIs. If you don't, I would really recommend, and we'll talk about different ones that you can interact with. But security needs to change. We need to de-silo, and we need to get tooling that we can plug into our GitHubs or GitLab CI/CD pipelines, or our Jenkins pipelines, so that we actually can have APIs that we communicate with to form a better security in that process. So we'll look at that here in a minute. Test-driven development, right? That's a really important aspect. Is writing unit tests. So I had mentioned, as part of what the developer can do on their local machine, is write those unit tests. Include the security tests. If there's a security flaw that's been identified in your repo, fix it, write a test that shows you fixed it. Then you make sure you don't have a regression later. So test-driven security, test-driven development, they go really well together. Container hardening, we talked a little bit about this already with CIS baselines. We need to secure our host OSs. Usually that's an operational job, right? We can't let the developer do all that. That's really not in the scope of their expertise or what they should do, right? So in this factory principle, right, the ops team is defining what a secure host looks like. What's the baseline? What are the knobs and switches? Security comes in and adds more security layers to that hardening of that host OS. Same thing. The ops team might pick what are our base images. What's our base image going to be? And then are we going to make sure, how are we going to keep that up to date? How are we going to patch it? Are we going to do that every cycle? What's our secure service configuration that's running in that container, right? And then what are the application? So everyone has a role here to work together to create these layers. And it works really nice in container land because you can layer the security in at every stage and you can all work from the same repo in those containers. So an example, starting with a really secure base image, like a Red Hat Universal Base Image 8, it's pre-hardened. They have a health index, and you can keep it up to date. So as long as you're running the sort of latest validated Red Hat UBI 8, for example, you're going to have a up-to-date patched host OS, at least with all the known patches that exist. This is going to help your vulnerability management programs, right? Your security team's going to be really happy. Your ops team's going to be happy. You're going to get a lot more green checkboxes on your vulnerability management of all your systems. Secure containers, container hardening. Iron Bank, so the DoD has worked with a lot of companies to come up with secure repos called Iron Bank containers. So if they've done all this work, why shouldn't we use that hardening work to grab their container definitions and run those on our secure base OS? That's going to save us a lot of step. And then we can scan that with the baseline tool later. But again, that's at the dsop.io/dsop repo 1. That's the Iron Bank containers. So here's an example, right? The secure base image is pulling from UBI 8 from Red Hat. They're pulling it from their base registry where they put all their images that they trust, that they vetted. They're going to layer in Vault. So this is HashiCorp Vault. It's a key management and encryption service. And they're going to pull that in from their base image. They're going to add a bunch of metadata that labels it so they can keep track of what it is. They're going to run the commands that harden that image. They're going to make groups. They're going to make users. They're going to expose ports. And they're going to make sure it's not running as root. They're going to do all the security in the Docker file. So there's a lot of security things you can do here to actually make it better. And here's how HashiCorp Vault defines their secure image for their product. So you grab their image. If you want to put a database out there, you can as well. They have a whole bunch of samples in that repo that are actually used by DoD. CIS benchmarks at the Center for Internet Security. You can download these documents that explain the hardening steps. If you're building your own images, you can bring those in, whether it's Docker, Nginx, or an Apache web server. Bind any service you need to add to your infrastructure. You can get a hardening guide as well. So let's talk about the build stage. So we're moving around that circle. And this is where you compile and build your software, you build your containers, your release packaging, storing your artifacts, build configuration, control, and audit. Again, at the build stage, we want to reinforce some of these things we talked about. And then they bring in static analysis, software composition analysis, which is really what are my third-party library dependencies? What are my base dependencies? And what is the patch set, and are they vulnerable, right? Do I need to patch them? Also, we might have licensing violations. If I'm writing a project and I incorporate a GNU public license library into my repo and I reference that library, that then dictates I need to release my entire repo under GNU. Well, if it's a private project or a project you're not willing to release as open source, you're actually obligated now to do that. And so there's licensing checks we can do as well. Test phase. This is where we want to run our unit testing. And again, this is happening on our development machine, and then we're moving into our CI/CD pipelines here as well, where we can actually deploy these and run them in a container on a machine, and we can exercise things through unit testing, integration testing, regression testing. You can host them in a staging or QA environment for that sort of testing, for penetration testing, and performance testing. So we want to look at the security specific things here. So we talked about container security testing. I'm going to give you a quick demo here on how to set some of this stuff up. Network security testing, compliance testing to meet CIS baselines, PCI DSS compliance, if you take credit cards, DIG for DoD, etc. Right? Dynamic analysis and security testing. This is a security tool that runs your app and tries to run attacks against it as it runs live. We'll demo that here too in a minute. And then interactive security fuzz testing. So if you have an API, you want to throw garbage data at it. If you have a Swagger file, you can actually fuzz that endpoint. And then you might throw out a bug bounty program or a red team to go after your app right before you roll it out to production to sort of check all those sort of more complex business rules you want to validate or things that you can't actually get from an automated tool. More sorts of things. We're talking about compliance scans. That's another important tool. So on and so forth. So for compliance scanning, there's something called OpenSCAP, and it'll actually scan your images to see if they meet a particular compliance level, right? So you can scan your image before you deploy it with OpenSCAP base. It's an open source tool. And you can run a daemon on your containers out in the cloud to make sure they haven't drifted or someone hasn't modified them as they run, right? As an example. So these are really important ways to monitor the compliance of your system as it's live running out in the operation side. But we're talking more about the base scan here, the baseline in the development and testing pipeline to prove that you've built assurance into your containers. And they have rules for operating systems, Chrome, Firefox, Java, JRE, and JBoss. They don't have everything, but it's a good base. And you can get tools that also support this as well. There's also the CIS Cat Lite tool is a free tool. You can scan your containers to make sure they meet the CIS baseline. And they'll tell you if something's configured wrong. Source code composition. What are the dependencies? What are the third-party libraries? Here, I'll do a demo here in a minute on these, but we'll be able to look in GitLab, and we're going to get a list of vulnerabilities in a project, and we're going to work through those. Container scanning. Do we have any layers of our container that have injected a vulnerable library that could put our system at risk? And we're going to use a tool called Claire to do that. It's an open source vulnerability scanner for container registries. There's dynamic analysis in GitLab. We'll look at that as well. And our license compliant. Did we violate the GPL by including it in our library based on the policy we wanted in our repo? So we can build a license compliance rule set that allows us then to make sure someone did not include a library that puts us at legal risk for releasing open source software. All right, then we're at the release deliver phase. At this point, let me let's talk about how we would incorporate these in our pipeline. So I have was graciously given access to the code.osu .edu website, and Jeffrey and I worked on this together, and he did a lot of good work for me as well to get this up and running, and he'll talk more about how to actually get this set up for real. But we just have a GitLab repo. It's got the OWASP juice shop. I forked from the actual one from the OWASP project. And I have some branches. And then they have a CI/CD here. And we're going to talk about pipelines real quick and how to add security into them. So normally at the first stage, if I commit my code, right, I just want to make sure my container builds. And that's a really, really useful thing to do. But we want to go to the next level and add security here. All right, so here's my Visual Studio Code. I could be using WebStorm as well, but I'm going to open a magical file that GitLab respects called .gitlab-ci.yaml, and this is how you build these pipelines. So we're gonna set up some basic things. Actually, I think I'm in the wrong folder. I have a couple projects. My apologies. Yeah, here's the right one. I have a couple versions of the app I use at different stages. Here we go. So this one's in WebStorm that I showed you the SonarQube lint. So we can see here I have a build stage. I'm just going to define it. I'm going to say I'm going to use a base Docker image, right? You'd want to make sure you have your secure images in here. You're going to build it. There's some Docker variables you have to set up to get this to work. But then we're going to run through the container build stage. And we're going to basically log into our Docker registry before. We're going to pull our image if it already exists to take advantage of some caching. It's going to basically run the Docker build stage for us automatically. So when we look inside this little bubble, we're going to see all the things it did for Juice Shop to compile it. So we've got a lot of fun things in here. So the GitLab runner picks it up. It gets it out of the repo. It's going to do the Docker build steps in the Docker file in that folder to build the container, which is going to run a bunch of other tooling to compile and make sure this is ready for some sort of release. So that's all fine and good, but let's say we want to add some more security rigor to our process. So we're going to need some more stages. Maybe I want to add like a linting stage because, just because it worked on my machine doesn't mean everyone followed the same rules. So maybe we should define a lint stage as well. And in that stage, right, I want to add a Docker run, the latest image, and then I want to call this run lint file, right, that maybe I have inside my container. And I'm going to run it through the Docker run command. So I can do that. And then what that's going to do is that's going to create a stage. Where'd my code window go? Sorry about that. That's going to create a stage in my pipeline that will now, after build, we're going to run a lint. Let's jump to the next one. So we're also going to want a testing phase. So you'd want to put all your tests, your unit tests, your integration tests, maybe in this phase, static analysis, all the security tooling here, right? So what can we do at this phase? And a really neat thing about GitLab is we don't have to do a whole lot here. There's a bunch of predefined templates I can just import, and there are containers that have security tools baked in. And there's no reason anyone can't make their own containers with their own security tools built in. But if with the Universal Edition, it comes with the container scanning, which is going to use Claire. It comes with a dynamic analysis tool, dependency scanning for third-party library vulnerabilities, license scanning for license compliance, and static analysis to make sure we don't have vulnerabilities in our code. Additionally, with the DAST stage, we need some rules because DAST runs on a live system as it runs. So it's going to have a website. This is going to be the demo.oauth-juiceshop. So it's the endpoint. Are we going to do a DAST full scan? What stage does this apply at? And then we're going to go in and grab the Swagger file, which defines the API, so we can run a fuzzer against it to make sure it doesn't have vulnerabilities in it. I think that's pretty much it. Let's also make sure we include that DAST stage, though, because we do have a DAST stage now, a dynamic analysis scan stage. So we have build, we have lint, we have test, we have DAST. Some Docker variables, some services we're going to rely on, build container, and again, lots of docs on this. And this effectively is going to get us a whole bunch of tooling in our pipeline. So I'm going to kick this off. It does take a little while to run. And then we'll take a break here in a minute as I'm going to check the code in here to the repo. And that's the other beautiful thing. We can show my differences here in my file, right? Before I commit it to the repo, I'm using SourceTree here instead of the command line, just for ease of demonstration. And I'm going to say add in security checking pipelines. And then we're going to commit and push this to the repo. Now, if the demo gods are good to us, this will go in there and we'll see what happens. So I'm going to push this up. I'm going to commit it and push it up to the remote repo. So everything completed successfully there. Let me find my code window. And now in our CI/CD pipeline, since the code just committed, it's going to pick that file up and it's going to start running us through all of our pipeline stages for build, linting, testing, and dynamic analysis. Pretty cool, right? So this is going to take a while. Why don't we take a quick 15-minute break? If you have any questions, I'll be happy to address those right in the channel, maybe when you guys come back from your 15-minute break. And then we'll jump back in and sort of talk about the sort of the next stages of the pipeline. And we'll be checking in on this over the next half hour to see how it's running. And hopefully it works well. Let's jump back in. Hopefully everybody had a quick break. If you look at the screen now, you can see I've had a pretty good run so far. The linting stage has run. The container scanning phase has run. Dependency scanning has run. And now we're on license scanning. And notice total, there's 7 jobs listed here. They're written as allowed to fail because a failure means it didn't pass the security scan. That doesn't mean you don't want it to continue on to the next stage and collect more assets. A security tab's popped up here as well. And we can start to see that we're getting some of our security information. Criticals, highs, mediums, we can filter on these for our container scanning, for instance, or dependency scanning, or static analysis, right? So we'll be getting some quick feedback here from the tool as it runs. And this becomes a really quick way for developers to know and solve problems they have without having to involve any security expertise at all, right? We can see that in this package.json, we have an out of bounds read and base 64 URL. We can dismiss it if it's fine. We can write comments to sort of dialogue about this. We can read about links from other sites that talk about the vulnerability in this particular package from HackerOne, for instance. So again, a lot of good information can be gotten. The severity is a high. And it's going to be clicking on this file, and we're going to be taken right to package.json, where this base64 library is included in the project. And this isn't something that you can just do in GitLab. If you happen to be using Jenkins, if you happen to be using different ones, there's Jenkins files. And the goal really is to create your own pipeline. So along with this, like I only put some of the security tools in here. You would want your end-to-end tests, your integration tests, your unit tests, and you may not want it at every commit, right? It's a long time to wait a half hour for a commit. And so you can actually add rules in your GitLab CI file or in your Jenkins pipelines as well to say, only run this on a PR or only run this before you merge to master. And you can put gates, and gates is a really important part. The earlier you put your gates in the development lifecycle, the easier it is to fix. That way it's not out in production. So again, we're on this last stage. We now have licensing information collected from our package, right? We can see all the licenses involved here. So that's helpful. The other thing I did is I went in and I put in, you can also put approvals in, right? So once you turn certain rules on, you can actually add an approval rule that will enforce that security check in the CI/CD pass. And you can say, well, just target master for this, or just target, and so you can write some rules around how you're targeting, or you can add people review. Maybe you want to bring in your security reviewers, right? And so you might say, bring in the CSD DevSecOps team to do reviews only when it goes to master. And so then you have a rule name required for merge to master. So you start putting gates in as early as you can in this process, and it's going to give people quicker feedback. Developers can get it on their IDE first, and then once they commit, and maybe right before their PR, you want to add more and more testing as you go through. And by the time you get to master, we're building in what's called assurance into our pipeline, so that by the time it gets there, there's an assurance that we've done at least a decent amount of work. That doesn't mean it's perfect. That doesn't mean there won't be security flaws. These static tools only go so far. And that's why we might want a merge request review. That's when you bring in people who can look at the code, who can maybe look at it for security implications, as well as just, are these people following good standards? It's a good way to make sure that things aren't missed. So putting gates in your rules, really important. Again, and that's not unique to GitLab. That works in Jenkins. That works in GitHub if you're using their CI/CD. This is built into all the tooling now. I think the nice magic thing that comes in from GitLab is these these template containers that they built in static analysis, they built in license scanning, dependency scanning, dynamic scanning, and container scanning. And that's a really, really cool feature. Now, I didn't turn on secret detection. That's in here in code quality. Some of these create large containers, and there's some administrative tasks to take care of and planning to make sure these work. You'll need certain size disks, because code quality scans from Code Climate can be very expensive. It's a pretty large container as well. And then you can build your own custom templates in here. So these are out of the box templates. And again, with code quality, right, you can, as long as you pass in the pipeline the path to the report file and it's formatted in a way that GitLab understands, or it's formatted in a way that SonarQube understands, or it's formatted in a way whatever dashboarding tool you're using understands, and you pass those on to the next stage of your pipelines, you're going to have a really powerful way to measure security through all of your pipelines as you're running your code. Looks like we passed. It looks like all the steps ran. And there you have it. We have a dynamic scan at the end with Z-Attack proxy. We actually spun up the container, and we did a fuzz testing against one of the endpoints. So again, you can integrate all these things within your pipeline in a very short amount of time. I mean, relatively speaking, when you consider what you need to do to keep good code pace and velocity in your pipelines, 21 minutes to get all this done and know that I have some level of security is really powerful. And now we go to the security dashboard, and we can look around at our project now, and we can effectively look at issues. Here's a private RSA key. We can click on these issues, we can click on the file, and we're taken right to this private key that's living in this, hard-coded in this file, which is a security violation, right? This should be in a HashiCorp Vault or in some sort of parameter store that encrypts data, as an example. You can dismiss false positives. Again, and so we can also, you can also say, well, we're only going to be able to solve for criticals and highs right now. So again, we have eight things to work through right now. And again, that's not a heavy workload. And I can do that now instead of like getting a security scan a month later from someone right before we go to production to say, oh my God, you have to fix these things, right? This is way earlier on in the life cycle and much more easily for me to interact with and fix as a developer. License compliance. You can build a simple policy. You can allow or deny. So here I've denied all the GPL and AGPL libraries. I say they're denied. And then when it detects them in the project, it just makes sure that we pass that policy. And so we have, again, a good experience. We can see that I've configured all of our secure features right now. And then there's threat monitoring we could add for live sort of monitoring of applications. We'll touch on later, but we don't actually have a demo of that right now due to limits in how we need to spin up infrastructure right now. But that is an incredible, and then of course we can see all our green checks here. And then if I want to go to my top level and create a merge request, right? It might run another pipeline. It's going to require a code review. We could also have it pass a security check. All the things are going to happen when we do our merge request to branch this into master. So again, really, really powerful capabilities with very little effort other than setting up the infrastructure and environments. And then once you can build your own security scanning tooling and containers, you can grow in maturity. But the one thing I want to also mention is start small. Try to integrate the small pieces, the small scanners. Don't try to boil the ocean. Take an agile approach. So add a little bit of linting here. Maybe try to add the container scan or dependency scanning there. Again, do what's quick and easy, and then iterate and try to incrementally make and add more security value over time. And again, you can see all these tabs are filled out now as well. The other nice thing is the security dashboard. So if you want to bring in a view of all the security across all of your projects, right, you can add all the projects you want. You can get that bird's eye view, high level of how all these repos are doing that maybe you're responsible for. And you can track it over time. So no surprise, JuiceShop got an F, right? It's got some issues we need to work out, and we can look at that at a high level. So again, the security dashboard will merge together a view of all your repos you want to look at. And you can track to see, because often remediation has a SLA, 30, 60, 90, typically for criticals and highs, might be 30 days, mediums might be 60, and lows might be 90 as an example. Whatever your policy is for vulnerabilities, this is going to help you see and monitor and make sure you meet your SLAs around security within all your projects as well. All right. Let's jump back into the presentation now. So once you move through that phases, and again, I don't have the additional phases, but the GitLab and Jenkins and all these pipelines and GitHub, they all have the ability, Circle CI, Travis CI, all of the Spinnaker, like you name it. There's a ton of different tooling out there that can monitor all of your processes from development, from once it hits that repo, through pull request, through code review, and on to when you're getting ready to release and deliver. And at that point, part of your pipeline can be to gather the docs and assets together and package them up. So you might need your design docs, test reports, threat model. Your threat model file is an XML file that I just showed you. You can check that into the repo as well. And someone can open that and take a look at it. If the security team needs to do a review, they just look in your repo. Again, it is the single source of truth for all security in your project. And they can load that threat model file in the tool and take a look at it and see if there's anything. And then if the penetration test team wants to take a look, or you have red teams, blue teams kind of set up, they can take those assets and they can work with them as well to help find other issues that may have been missed. And there's release no-go. So as I said, move all the gates as far left as possible, the blocks. Don't let stuff go to master with security flaws unless you've accepted the risk and understand what that risk is. Again, it's not saying no to everything, but it's really like, let's understand what we have. Let's apply science and data to this process so we can actually see if we need to go to the next stage in the pipeline. And then tagging things, right? So you know what artifacts are in production, so you can recover back to previous versions as well. And then, you might need to distribute these all to all your regional repos if that's a thing that you're doing in the cloud, for example. Again, this is the DoD's heavy things. These are just things you might do, not things you have to do. Again, I would recommend you design processes that really work through here, that check your security and meet your security policies and compliance within your organization. So release packing tools, you want digital signatures, you want to make sure those assets. And again, no one should be able to jump code in that pipeline. No code should ever go to production without running the gauntlet of all the security checks and reviews. That would be a complete violation of this whole principle. So here's what that sort of looks like and kind of what I just demoed with GitLab. Again, you can do that with many, many other tooling. We just wanted to use one that we had available to all of you already through code.osu.edu. So again, we showed the security here on the IDE side, putting those into the repos, running these through parallel pipelines for maybe all the projects and all the different repos and different teams. And those then end up in an integration pre-production environment as well. And then finally, during continuous deployment and delivery, we have this release packaging, and those go into an artifact repo, a Docker registry, a artifactory, or something of these natures, or a combination of things, so that you can actually have the signed assets stored, and so you know exactly what's in production and what pipeline it went through and all the artifacts that applied to it. So then we're up in the deploy stage here. So we have security configurations. So those should be pulled out of your config management databases, your parameter stores, your HashiCorp Vault for secrets, or some sort of KMS system that manages keys for encryption to store all your secrets as well. You don't want those hard-coded. You don't want them just sitting and playing config files all the time. It's better to grab them out of a secure store and then drop them into the environment as they go out to production. And no one should have access to those except those particular items running in production. Again, here's where we get more into the philosophy of DevOps and DevSecOps if you're running that pattern. If you're not, and you might have administrators on those servers administering those secrets as well, and that's not an uncommon pattern. as well. But the more we can automate even our secret delivery and deployment to those areas, the better. All right, again, just more things. So operations here, this is when, we're dealing with, SLAs, key performance indicators, backup and recovery, high availability, load balancing, and all of that for pretty heavy duty sites that we might need to maintain and keep operational. And so we want a series of operational dashboards as well. I mentioned OpenSCAP because, again, you can put agents on machines, or if you're running something like a Prisma Cloud or Twistlock type technology or Kubernetes sidecars or any sort of technology that layers security on and can monitor things as they exist operationally. You can check for system drift. You can check for violations of policy. Someone touched a folder and a file they shouldn't have, right? That's all the information you can gather with a tool like OpenSCAP, or there's a lot of security tools you can buy as well that handle these things as well. And you want to make sure you're actively monitoring for vulnerable libraries that we learn after the fact, after we deploy, become vulnerable, as well as signs of compromise, security configuration changes, or people on hosts changing things, causing system drift that shouldn't, right? To get a system change out, we should go through that whole pipeline again, that whole gauntlet. No one should be changing anything in production without it going through those pipelines. Monitoring. Again, lots of things we can monitor here. I want to touch on a couple. Specifically with logging, this is what's in scope for developers in particular. But there's a lot of other logging and auditing we can do as well. And I want to talk about App Sensor real quick. This real-time threat detection tool. It's an OWASP project. It's not in constant. It's not up to date maintained. I think it could use some refreshing. But the principles here are really what I want to convey. Not that you should use this, but that we can derive from this requirements about attack data as we're logging and monitoring threats in our applications, because we have network security sort of nailed down. We understand with web app firewalls as well as intrusion detection and prevention systems we may have on our network. We can see a lot of things, but once someone logs into an application, I feel like we're flying a little bit blind at that point. It's hard to check, like WAFs don't know the context of a request. They don't know about business rule violations. They don't know about a lot of other things. So they're kind of like, I like to liken them to like bad antivirus. Like you have to and want to have them, but you want a little more advanced security in your logging. And App Sensor presents a model and design pattern for that. And that's what I want to talk about real quick. So the architecture for this is pretty simple. You have your application you built and your log server. This is all very common. It could be your SIEM or something like that. And then there's this sort of tool that runs over that and is monitoring this log data. Call that the App Sensor brain. And it has a feedback loop back into the application that has a response listener running, right? And that response listener can create an security intelligent application that can respond to active threats with very simple logic. It's actually not as complicated as I'm making it sound. You can warn users of misbehavior. You can auto log out users. You can disable users. You can lock out. There's a lot of things we can do with this simple feedback loop. So for a reference implementation, right, we may have our web app firewall, network intrusion detection, and all our app logs going into this sort of pile of data with some policies for monitoring. And then we have ways to sort of visualize this data out through analytics, SIEM, data visualizations, and whatnot. We want to support things like correlation and scale as well with this. So what do we need to log? This is a question for app developers all the time, and what we find is most of the time it's not sufficient. So this is a really good model for how and what to log within your system. So we always want our time and date, security event, in particular, if it is a security event, and that's what we're talking about here, not general logging. You want all the general logging you normally do. It's the security logging that we want to enhance. So we're going to have security event types. We're going to have severities and confidence. And this is really the thing we're adding that might be different than what you're used to logging historically. Again, all your sort of normal, like which host did what on what port and protocol, what HTTP method, what's the entry point, what user, what's the user agent of the client, what's the client fingerprint. And then the app sensor may enhance some of this with things it sees with sensor location and ID. Things within the request body and stack and error message trace you might want to that are optional. Don't log privacy data, please. Like, make sure you're not logging PII, passwords, sensitive user information. And you need to anonymize those somehow before they go to the log, so that if you need to resolve them, you can. But if you need to forget about them, you can as well, if you remove the original user record. And then finally, we need record integrity. We need a HMAC. We need to digitally sign that record to make sure it's not been tampered with after the fact. So here's an example. This would be a request exception, type 1, RE1, and it's going to see an unexpected HTTP command. And it's going to your application is going to throw a request exception. And this is when an HTTP request is received, which contains unexpected or disallowed verbs, HTTP verbs, like maybe I expected a get and got a post on this endpoint when I really should only support one, or maybe I got a delete, or maybe I got a head, or maybe I got, one of these other verbs that we don't support on that endpoint. If our app never touches those verbs when it makes calls back, it's a good indicator of someone trying to mess with your application. So these are good exceptions to throw and monitor. So that's an example. And there's really 3 detection point categorizations we want to look at. There's discrete exceptions, and those are things that are activated without any prior knowledge of the user's behavior. It's effectively one request had something that looked odd in it. Then we have aggregating requests, where we need to look at several prior identical events. So someone's like trying to brute force in, or maybe they're scanning our website and we're seeing this repeating event across our logs. That's an aggregating event, which takes multiple requests to view. And then there's the modifying events. These can be used to alter detection thresholds. So if we get a feedback from the app sensor into our app that says, like, this particular user is behaving a certain way, you can actually automatically have the app change its log level, and it can increase it to collect more data. So you're not always collecting all this data. You can actually have it elevate log levels. You can automatically log that user out. You could turn off administrative interfaces or certain high-risk functions for that user. So you end up creating a security intelligent application that can interact with that as well. Here's some examples of some of the detection points you could look at. We already saw a request detection point, but again, there's a clear defined taxonomy of these in the application. So like as an example, unexpected HTTP command we looked at, attempt to invoke an unsupported method. So someone ran something that isn't even a legal verb. Opposed to an expecting get, and there's a whole bunch of these you can look at. Authentication examples, use of multiple usernames. The first user first tries username Bob, and then username Sue, and then username Steve. So this is an aggregating event. Someone's trying to rotate usernames, probably by using a top 10 vulnerable password or something like that. So they're not triggering lockout, and often these events go undetected in some cases. Multiple failed password attempts, failed pins, invalid mobile auth codes, things like that. You can log those. Encoding, if you find double encoded characters, that could be the sign that someone's trying to inject some cross-site scripting or other issues in your application. Unexpected encoding use as well. If we see UTF-7 show up somewhere, that would be super weird. We wouldn't normally expect that, or any unsupported things. So how would you incorporate this into your application? So if you look at this JSP sample, right, we have sort of these layers of authentication that's sort of governing every page to make sure the user's authenticated and authorized. And you might have some request exceptions you always monitor around those areas. And then in home JSP, you may look for just a request exception 4 on some REST endpoints. Update profile, there's an input exception, maybe someone's violating your input validation rules. They may be exceptions you're already throwing, but if you log them, you actually give data that you can use to react in your system and make it a little more intelligent, so on and so forth. And what would the code even look like? How complicated is this? So for instance, if a reference ID is a valid user or it's null, right, you just throw a new exception, and it's an app sensor intrusion detection, as in this reference example. And then it's going to pass in the data. It's ACE1. Here's the user context. Here's the message the context so that if security reviews the log, they know what that part of the app does because the developer actually wrote it in the message. So when it ends up in the logs or in the SIM, you can actually see there's documentation that actually lives along with that exception to explain what was going on, right? Direct object, so if you can add tampering to your log messages, your security teams can actually read that and they don't have to call anyone, right? Or figure out what your code does. They can just read it in there. And so there's this behavior continuum as well. We have normal application use on the right, unacceptable on the left. We're not trying to find everything, right? Most of the things are going to live in that greenish zone. All we really have to do is identify those far left ones to get value out of this. And it's pretty quick and easy if you've ever done any or seen any sort of penetration testing or a malicious user behave. They set these rules off pretty quick. And on average, I think it could take 7 or 8 requests for an attacker to find a vulnerable portion of an application. But App Sensor could potentially respond in 2 to 3 or 4 requests. All you have to do is respond quicker than the attacker may find and exploit the vulnerability. And then you can block them, or you can alert the security team, or you can monitor more closely. You don't need machine learning, you don't need AI, you don't need big data. It's a very simple rule set that can get this done. And it makes apps context aware. Just as an aside, GitLab supports mod security, WAF, web app firewall, so you can actually monitor live in GitLab an application and more of anomalous use and things like that. Combining these things together, you could create a really robust network policy and application use policies within your apps with rules that can automatically make your app respond in an intelligent way. So I think that's really pretty cool. All right, feedback. So there's this feedback loop. Again, we have feedback coming from our continuous monitoring. Gives the system out of compliance. Maybe you knock it down and spin up a new one that's back to normal and make sure someone goes through the normal process. It's easier to do with containerization and more of those sorts of architectures. It may be a little harder with sort of an older style application. But even just knowing that system drift happened, if people fix things on the server and forget to put them in code, it's good to know about that. So you have a feedback loop that tells development and operations and security to incorporate new version, new secure base OS. Back through that feedback loop, you run it through all the tests and you deploy it to production again, so you can actually keep things patched and up to date. You may have a shorter loop to keep OS patches in, where you're not even going back to dev for the base OS image update. Maybe you're just updating that base OS and then redeploying without going through everything. If you know that you're not going to impact that application that's running in a container because the host OS just needed a patch, right? So you want continuous feedback for all these things. And an immutable paradigm is a really nice model to take. If no one's allowed to technically modify anything in production, it has to go through this process. You're going to have a really strong assurance that everything is as it should be in that process. So what do we want to measure as well? There's a lot of things we can measure. And GSA.gov talks about DevSecOps maturity model. They have levels and they have common things to measure, which your CI/CD systems can measure. You can put them in dashboards, and you can collect this data and you can feed back into the system. What's our time to value? How long does it take for a feature to get to production? What's our time to authority to operate, ATO, or how long does it take us to get through all the security checks? Because you want to be improving these times, right? How long does it take to patch vulnerabilities? Are we meeting our SLAs, our 30, 60, 90-day SLAs for vulnerability patching for our vulnerability management programs? Customer issue resolution time. Someone opens a bug, how fast can we get that bug fixed back out into production? So these, again, as you increase velocity and increase security, that gives you the ability to actually fix a security flaw more quickly, as well as a lot of other valuable things you provide just that you get from velocity of this type of program of DevOps. Percent fixes, feature security patches, things like that. And then, so those are sort of really important ones they talk about. There's tons more you could dive into. How many unit tests, integration tests are we running? What's our code coverage? What's our mean recovery point? What's our change lead time? The delta to commit versus a deploy. Like, how fast is code moving through this pipeline? Again, you can define sort of what you want in that space. And that's pretty excellent automation, I think, that sort of has been missing, and a lot of work and tooling is going into adding security at every stage. So that historically it's been like, try and code better, work hard, patch everything, and there's not a lot of tooling to solve the problems without spending the big budgets and a lot of money. There still is potentially some of that to meet compliance, but there's a lot more tooling available now in these pipelines that can make this a lot easier. So again, we talked about planning and threat modeling. We talked about the development stage where we employ secure coding practices from the application security validation standard, as well as knowing our language and incorporating things like code review and things like that to make sure our developers, through education, are writing secure code. Security as code, where security teams partner. They build templates, they build APIs, they build containers with security tools they can put into your pipelines, into your repos, and registries to make sure you can actually scan and create assurance before you ever get anywhere near production, earlier in that life cycle. And that's a really critical step. And then through the build phase with static and dynamic analysis, as you move into test, you could throw some pen testing right there once it's in QA. Again, if you're working and you have a lot of these assets, the security team has access to all of your security scans and your CI/CD and the outputs, as well as the threat model. The pen test's you're gonna save their time looking for super easy, obvious things and focus on the more critical. Sign release, secure transfer, config management, security scan. The nice thing here about over on Operate is adding like a Z-Attack proxy over there. Do some smoke tests. Make sure your headers didn't get removed by the production server. Make sure SSL TLS is right and you don't have expired certificates. Like there's a lot of things you can do as you move around this deploy scan with smoke tests and things like that. Again, and then security patching as you operate. If you need to patch some base layers of containers, you might have to pipe it through the entire process again because updating libraries can have breaking changes to development code. So you want to have some good testing in there as well. Security audits, again, should be, you have all the assets, you've generated them all. The audit should be easy. You're checking the box at this stage. Security monitoring, we talked about using tools like web app firewalls, your IDS, IPS, WAFs, and then incorporating security monitoring into your application. That's a really important aspect too. And then analyzing all this data as it goes back into the next planning cycle and the next iteration. And that's effectively what we're talking about. In 2 hours, DevSecOps at a very, very high level. You can dive deep into all these areas. And depending on your role, you'll want to dive deep in your area. And so if you don't live on operations side, you're a developer, focus on that left-hand side. Let the ops people focus on the right. You'll want to work together, though, to come up with standards and ways to communicate these facts back and forth to different teams, as well as your security teams who are adding and helping you layer in the security. Again, giving you guidance and input on certain vulnerabilities and risks related with them and whether you should patch. But if you just decide to always patch your third-party libraries as much as you can and your container layers and OS libraries, that's going to go a long way with these security scans to get you where you need to be. So the problem, again, let's reread this Gene Kim quote because I think it's really good. The problem for the security person who's used to turning around security reviews in a month or 2 weeks is they're being shoved out of the game, right? So also there's often not enough security people, right? So if we can build these templates, these reusable APIs, these containers, you can work at the speed of development at the developers and layer security in, and that's super valuable. So we don't want to get InfoSec shoved out. We want to bring them in. That's going to require education and knowledge, and learning a lot of these modern tool sets with DevOps and DevSecOps. Now I have some more demos. I'm not done, but that's the presentation. I wanted to show a few other tools. If there's any questions, now is also a good time to add them in. And I think I'll spend another, 10, 15 minutes here showing off a couple other tools that I think may be valuable. All right, so this is Juice Shop. So there's a new technology that's come out over the last few years and Microsoft has acquired the technology. And they're integrating it into GitHub right now, but it's an open source project that has very powerful very powerful static analysis rules for languages, and it's called CodeQL. And it's a way we can write our own static analysis tools. So most static analysis companies are black box. You upload your code, your binaries, whatever it is, they run through your code and they tell you where the flaws are. And they're effectively doing taint flow analysis, following in data from sources, which is external systems, through the system out to sinks, which are areas data can land that's untrusted that causes a security vulnerability. And so through CodeQL, they've created a way to basically take a code repo, create a database out of it that compiles all of these pieces of information of the structure of your code, kind of like a graph database, and it follows these through with custom rules you can write. So for an example, I've cloned the CodeQL repo from GitHub. And we can go and let's look at some security rules. And the nice thing about these is they even have CWEs, these common weakness enumerations they've included. And you can actually look at this language they've developed, which is a complex sort of way to follow taint flow that you can represent in your own language through these QL files. Let me try to find a simpler one here. These are kind of, here's a nice simple one, right? So this is CWE22. And so you kind of import some libraries, you put some metadata on top, and you're defining a flow in this language called SIML that if you have a flow path from the source to the sink defined in this way, you have that has to do with particular zip slip rules they have built in. It will query your code base and tell you where those flaws are. What this does is this opens up the ability for you to write static analysis that works for your libraries. Historically, you're not able to do that. It's a black box. So if you wrote a custom authentication module and the static analysis tools don't know about it, they miss all of those sources and sinks. And they can't really do a good job scanning that. The neat thing about this, let me open my terminal window. And so I have, whoops, I started the query. I have a little shell here, and I created a database with the CodeQL tool. And again, this is just going to show the thing we're going to do. And we're going to actually, I've already built a database with CodeQL create command, and on this particular juice shop repo. And that is going to let me run now a series of, so I'm going to run CodeQL, and I'm going to tell it to analyze the database, which is this JavaScript database I created. I want it to output a CSV file, and I want it to write to this file here and use the JavaScript CodeQL suite for security and quality. And when I run that, it's going to compile and run, interpret the results. So I pre-compiled these, so it's really fast, right? To compile it takes a time because it uses that database and then combines those rules in there to pre-compile these static analysis rules. And then when you rerun it, it's very quick. And let me see if I can open the file now it just created. I'm going to open Excel here. And now we have, and you can get JSON. There's a common static analysis format that you can put into SonarQube. You can put it in other places as well. You could translate it to live in GitHub as well. But we're actually now getting, line of code, which file had the vulnerability, using these custom rules. Like here's the hard-coded value of the private key that we found as well. Again, hard-coding credentials and source code. So again, our tools are finding common things among them, but this is really good because it doesn't end up getting as many false positives as a lot of the other tooling does. That zoom is a little better there, sorry. So database query built from user-controlled source, right? It's finding SQL injection. And we'll find through this Juice Shop project, I found this probably has more accurate results. It also has code quality like semicolon insertions are hard to maintain, variables not declared. So it's doing types of linting for code quality as well as security rules as well. And so this is an open source MIT project from SIML that again, Microsoft has acquired through GitHub as well, and they're integrating it into their own pipelines as well. And the other site's called Looks Good to Me is sort of the, if you've heard of that site, that's what's using all this. But again, it's another really, really powerful tool to add if you want to bring in static analysis as well. What else? I had one other thing I wanted to run through. Just for documentation, again, on what GitLab offers. Again, and I really like where they're going, how they're bringing security in. They define stages in their pipelines, but mainly their application security section just talks about the templates you can include. So here we have our, dependency scanning, license, secret detection, so on and so forth. And there's a whole series of them. Again, you can include in all your projects. Some require more config than others, but again, I found that they're incredibly easy to integrate into pipelines, which makes them incredibly valuable from a security perspective. So there's really, really good documentation they've written as well. So I've been impressed with not only their ability to make it simple to put it in pipelines, but also to track down issues and solve problems through their docs. Again, it's really, really powerful stuff. Thank you for joining me for this session. I hope you have a great rest of your cybersecurity day. And again, let me know if you have any questions or thoughts. Love to hear feedback. And if you know of any great tools as well, please do share. I like researching those and using them in pipelines and in projects. So again, thanks for having me, and have a good rest of your day.